Alright, on to the unbiased Monte Carlo estimator. So, as we talked about in lecture, we can use the Monte Carlo method to estimate some integral. And if we do it correctly, we can create an unbiased Monte Carlo estimator where the expectation of this estimator will be equal to the true value of the integral. So in this question, let's say we have two random variables, x and y, which are drawn uniformly from -2 to 2. What is an unbiased Monte Carlo estimator for the given integral? Okay, and then right here, I've just written the more general case for a Monte Carlo estimator. So given some one-dimensional function, we can estimate our integral of f of x here with this equation. This is just from lecture. And then in this question, we actually have a two-dimensional function. So our function takes in x and y. We also looked at this in lecture for a three-dimensional case. This doesn't change a whole lot. So it actually ends up only changing the probability that we calculate. So this summation part stays the same since we're still only taking n samples. Even if it's like two-dimensional, we just like each sample has an x and a y. And then this will be the argument to our function. So it would be like some xi, yi, which are drawn from x and y, our random variables. And then we divide by the probability of sampling xi and yi. So this is the one difference here. So what is this probability? So, alright, so we have two random variables, and they're uniform random variables on this like interval, -2 to 2. And so we're going to assume these are independent since they didn't say that here, but it's independent. And so this will just be pxi multiplied by pyi, and the probability of drawing some value uniformly on this interval is just going to be 1/4 for each of these. So this is going to be 1/16 in total. And then I'm just going to simplify this a little bit. So this will be 16/n. And then we'll just have all of the samples of our function. Alright, and this will be our Monte Carlo estimator.